Hello, today we're going to talk about absolute value expressions and we're going to solve equations. So if you remember, the absolute value of something is just the distance from zero. So if we say the absolute value of 2, well here's 2, well I can't get it to write, is 2 hops from 0. And the absolute value of -2, this is really messy. Sorry. Okay, I don't know why it's doing that. But anyway, so you get a line, and you're going to put in -2. Oh, Lord. Give me a minute here. All right, we'll do that on the next one. But basically, it's the distance from 0. Let's go on and look at something else. So let's simplify these. So you're going to simplify absolute value of 9 minus 12. Well, the absolute value of 9, how far is 9 from 0? It's 9 spaces from 0, so that's 9. And then we're going to subtract 12. So that's going to give us -3. My stylus isn't working. That's what the problem is. Okay, so -3 is the answer if you do it that way. But let's say you put the absolute value symbol around the entire thing. Well, 9 minus 12 is actually -3. And then we're going to take the absolute value of that. Well, how far is -3 from 0? So if you drew a line, and this is 0, 1, 2, 3, how many hops is it? It's going to be 1, 2, 3 hops. So the absolute value of -3 is 3. See how these are different based on where the absolute value symbol is. Let's go look at the next one. All right, so you've got simplifying the opposite of the absolute value of -4. You have to do what's inside first. So the absolute value of -4 is 4, and then you're going to make it negative. So the answer is -4. Try the next two on your own, so hit pause. Okay, so you should have hit pause, and now we're going to work this inside out. So we're going to do what's inside here first. We're going to square a -2. Well, -2 times -2 is +4. So now we're going to take the absolute value of +4, and then we're going to make it negative, because we're going to take that negative sign and put that over there. So 4 is actually 4 spaces from 0, but then we're going to go make it negative, so the answer here is -4. So both of these are -4. All right, let's try the next one. Should have worked it out on your own. So now we've got -2, and we're going to take the absolute value of it. Well, what's the absolute value of a -2? It's just going to be +2. Then we're going to square it, and that gives us 4. And then we're going to go and take the opposite of that. So we're going to have -4 again, because the exponents happen first, and then we take the negative. So these all end up being -4, even though they all look very different. Let's look at something else. All right, so let's look at equations. If the absolute value of x is 2, that means, now here I can draw this a little better. All right, the distance from 0 is 2. So it could be either two numbers. It could be 2, which is 2 hops from 0, or it could be -2, which is 2 hops from 0. So this basically means distance is 2, and distance can never be negative. That's why it's always positive for absolute value. Let's try this. Now here's how you solve one of these equations. It says the absolute value of x plus 2 is 7. Well, that means that what's inside of there could be positive or negative. So we're going to have x plus 2 can equal 7. But everything inside of there could also be -7, because once you work it all out, -7, the absolute value, that's going to be +7. Let's go solve each one. Subtract 2, x equals 5. Subtract 2 over here, subtract 2, x equals -9. Well, let's check. Plug it back in. So you've got the absolute value of 5 plus 2. Yep, that's 7. And you've got the absolute value of -9 plus 2. Well, that's the absolute value of -7, and that is 7 also. So that's why that works. Let's try another one. It says it is common knowledge. Let me pull this over, you can see it. Person's normal body temperature is 98.6. I'm going to let you read that, and then we're going to figure out what to do. All right, so you read that, and it says, basically says it can vary 0.5 degrees from the norm. So this is how you would set it up. You would say their temperature, and then you would take away the normal, and then it would be, that's how it varies. So let's see what it can vary to and from. So we're going to set up both equations. So T minus 98.6 can equal 0.5. All right, or T minus 98.6 could equal negative 0.5. And get a little squished here. Let me move this over. All right, so now we're going to solve it. So add 98.6 over here to both sides. And we're going to get T could possibly be 99.1. So 99.1 degrees is still pretty normal. Let's go ahead and do this one. Now I add 98.6 to this one. And we're going to get T is equal to 98.1 degrees. And that's still considered normal. And that's how that works. Okay, let's go try a couple others that are a little bit harder. So now we want to solve these equations. So we're going to first isolate the absolute value symbol. So everything has to go away from these guys right here. So let's add 4. And you're left with the absolute value of 2x minus 3 is equal to, now remember these canceled out, all right? Additive inverses is equal to 7 because 3 plus 4 is 7. Now we set up two equations. So we have 2x plus minus 3 equals 7. And then we have 2x minus 3 could equal negative 7. Now solve both of them. So add 3. And you get 2x equals 10. So x equals 5. Add 3 over here. And you get 2x equals negative 4. So x equals negative 2. There's your two solutions. Let's try another one. All right, same thing. Isolate it from the absolute value. So we're still going to solve it as just as if it were, just think of it like that, okay? But it's really not like that, but you would subtract 3 from both sides first, so we do the same thing. So we're going to subtract 3, and we get 2 times the absolute value of 5x is equal to 13. This is not going to turn out well. And then we're going to divide by 2, and we get the absolute value of 5x is equal to 13 over 2. And that's okay, we can deal with fractions. Okay, so now we've got 5x is equal to 13 over 2. And 5x is equal to negative 13 over 2. All right, now we go on and we trying to move the screen a little bit. It's not going to work. So let me erase a little bit of this work up here. So we've got, let's go and solve this left-hand side first. And we've got, so we had 5x equals 13 over 2. Divide both sides by 5. That basically means multiply by 1/5. You're going to end up with x equals 13 over 10. That works. All right, over here you divide both sides by 5 or multiply by 1/5, 5, and you get x equals negative 13 over 10. Now it doesn't always work out that way, but in this case it did. All right, let's go see another one. Let's try this. Now you got a variable on both sides. This one's going to be a little trickier. You already have this isolated. So there's not anything else you can do. You have to set this up as positive and negative. So we've got y minus 1 could equal exactly the way you see it, 7y minus 13. You also could have y minus 1 is going to be the opposite of all of that. Now, the opposite of all of that, you got to change all their signs. So it's going to be negative 7y plus 13. So that changed the signs on the right-hand side. Now you solve both of them. There's two equations here. So I'm going to move my smallest variable first. And I get negative 1 equals 6y minus 13. And add 13 to both sides. And I get 12 is equal to 6y. So y is equal to 2. All right, do the same thing on the right-hand side. Move my smallest variable. Now, negative 7 is smaller than 1y, so I'm going to add 7y this time, just to keep them all positive. 8y minus 1 equals 13. Add 1 to both sides, and we get 8y is equal to 14. And then divide by 8, and you get y is equal to 14 over 8. Let's go put that in lowest terms. So 14 over 8, 2 goes into both of those, so y is actually equal to 7 over 4 in lowest terms. We have two answers that are completely different. All right, why does this equation have no solution? Well, let's think about it. It's saying that the distance is, this equal sign means is, and that number is negative. Now, can distance ever be negative? No. So that one is no solution. All right, I have an assignment for you, and I am going to post it on another page on the same post. All right, have a great day.